Let me give you a couple of examples. I want to determine cosine inverse of cosine negative pi over 2. What would you be tempted to write? Right. I would be tempted to write this. However, this is not correct. How come? Because negative pi over 2 is not between 0 and pi. Okay? Let's say, how do I still determine this? Step by step. I have to use step-by-step procedure. I have to find what cosine of negative pi over 2 represents, and then cosine inverse of that number will give me something. Before I finish this problem, I want to come back here to the graph, and I'm going to ask you, my graph is not perfect, what type of function is this? Is it symmetric?
Yes.
With respect to? Good. Which means cosine of negative x is the same with if it's symmetric with respect to the y-axis. That would be with respect to the origin. We already exhausted that. We said there are 4 odd functions. Done. What is the other property?
Cosine of x.
Yes. What does this mean? That the function is?
Even.
Exactly. There is only one other even function, which is a function that has only cosine in it. Which one is that? That's it. So there are only 2 even trig functions. So secant negative x is the same with? Four odd trig functions. Any trig function with sine in it, it's odd. And only 2 functions are even. Plain cosine and the other one that only has cosine in it. Okay? Everything else is odd. Very good. Why I need this? Because you don't ever have to think in terms of negative angles. How much is cosine of negative pi over 2? Exactly, because it's an even function. So then I continue with cosine inverse of cosine pi over 2, and now I'm in business and I'm done. What is the answer? Yes, because pi over 2 is in this domain. So always remember, never ever have to deal with negative angles. But you have to remember there are 4 odd trig functions and 2 even trig functions. So if I'm asked, and this will come up, right, in the next work or test or so on and so forth. If I'm asked to find tangent negative pi over 4, what will I have to write first and not have to go around the unit circle in a different way? In a different direction. What will I write first? It's an odd function. Exactly. Exactly. Always think in terms of, oh, well, I know it's an odd function, which means tangent of negative pi over 4 must be negative tangent pi over 4, and I'm done. So now, what is tangent pi over 4? And you can say, you just told us not to remember. Fine. But you have to remember that it's sine pi over 4 over cosine pi over 4, and this is the only angle with the same sine and cosine. So tangent pi over 4 must be 1, with minus in front, negative 1. So if it's a waste of time to ever think in terms of negative angles. Once you know that 4 functions are odd and 2 functions are even. Okay, let's look at a couple of transformations on cosine. Of course, the period for cosine is still 2 pi. So let's look at f of x. Let's say -2 cosine x plus pi over 6 minus 3. Same questions. The amplitude for this function is?
2.
Yes, the absolute value of -2, which is 2. The phase shift for this function is?
-5 or 6.
Very good. The period for this function is? Same thing, 2 pi divided by the coefficient of x, 2 pi. And now the interval is still the same, b plus the period. So where this is -pi over 6, comma, -pi over 6 plus 2 pi. So this is -pi over 6, comma, 6 times 2 minus 1, 11 pi over 6. Of course, the vase will be reversed. Why? Because of the negative in front, right? It will also be stretched, but upside down. And also, what will happen after that? So first, I will have to shift it to the left, pi over 3. Then I will have to stretch it. Then I will have to reflect it. And then down 3. Why do I need all this analysis? Because I need to find the viewing window. One more time. So the vase, right, is cosine x. I have to shift it to the left, pi over 6. Then I have to stretch it, factor of 2, right? And then I have to reflect it, and then down 3. So let's go to y equals. I do have the x. I need x to be between -pi over 6 and 11 pi over 6, but I don't know how high and how low, right? So I know that without this, it will go high to 2 and low to -2. But 2 has to be moved down 3. So the high will be at -1 and the low will be at -5. Exactly. So that's all I need to see. Let's say between -6 and +1, so I can see the x-axis as well for the y value. So -2 cosine.
You're on the
Oh, sorry. -2 cosine x plus pi over 6, x plus pi divided by 6. Close the parentheses, and -3. The viewing window, -pi over 6, 2, 11 pi over 6, with a scale of, good, very good. Y minimum, definitely -6. Y maximum, let's put 1. Scale of 1 is fine. I should see a complete reversed graph as I was expecting, starting at -pi over 6 and the complete vase. Cosine. Any questions? Okay. Let's look on page 396. I think we graphed enough functions. I just would like 396, page 396. Any questions? As you see, all these problems require a calculator. So I'm more interested in a word problem here to see the applications of sine and cosine. Sound vibrations, blood pressure, variable stars, composition involving such and such. Okay. Any interest? Blood pressure, fine. Each time your heart beats, your blood pressure first increases and then decreases as the heart rests between beats. Arib is an expert in this. So the maximum and minimum blood pressures are called the systolic and diastolic pressures, respectively. Your blood pressure reading is written as systolic/diastolic. A reading of 120/80 is considered normal. A certain person's blood pressure is modeled by the function. Look at that. It has a sign in it. So let's copy the function. So this is problem 79. On page 397. Okay. So P of t is 115 plus 25 sine 160 pi t, where P of t is the pressure in millimeters of mercury. So this is pressure millimeters of mercury. At time t is measured in minutes. First question. Find the period of P. How do I determine the period? Nico, are you okay?
Yeah.
You tired?
Yeah. 2 pi times k.
2 pi.
Times
Careful. 2 pi over k.
over k. Yeah.
Over k. 2 pi over k.
Is 165.
I want to say something. You remember when we studied transformations? We had transformations, shifts left and right, right? When I change x into x plus 1 to the left, x minus 3 to the right. Then when we change y into y plus 1, y minus 1. And then stretches, right? Vertical stretch or vertical shrinking. And then reflection. What was the last one?
Horizontal stretching and shrinking.
Right. What did I say about that horizontal stretching and shrinking? It's the only one that kind of strikes us.
Yeah.
We didn't expect that f of twice x to do this. We expected that f of twice x to do this.
Right.
But it did the opposite.
Right.
So what is the period of sine?
2 pi.
Right. So in other words, from 0 to 2 pi. The period of this would be 2 pi divided by 160 pi.
That's small.
Although it's multiplied.
Right.
It's that twice x that you would have expected to do this.
Right.
Instead, it's twice x. I didn't have trig functions then. That's why I couldn't refer to this, but this is the best example. So the period is 0 to 2 pi. If I have twice x, it's going to be 0 to pi.
Right.
If I have 4x, it's going to be 0 to 2 pi over 2.
Yeah.
Not the other way around. But I couldn't use this. So this is 2 pi divided by 160 pi. As you see, it's going to be so much smaller. Yes. So it's 1 over 80. Find the number of heartbeats per minute. 1 over 80. So graph the function, we will. Find the blood pressure reading. How does this compare to the normal blood pressure? So a reading of 120 over 80 is considered normal. So let's go to y equals. By the way, which which interval will I use? And what is the amplitude? Because if I don't know the amplitude, I don't know what to do and what viewing window to use. What will be the amplitude for this?
25.
25. the absolute value of 25, which is 25. How high will this be? It would be 25 because this cannot be more than 1, right? This cannot be more than 1. So 25 times 1 plus 115, which will be 140, right? And how low would it be? The lowest that this can be is what? Negative 1. Negative 1 times 25.
Negative 25.
And 115 minus 25. 90. Correct? So I have to present the viewing window between at least 90 and 40. Exactly. So 115 plus 25 sine. Oh, of course. 115 plus 25 sine 165. X, we don't have t. Good. Now we have to wisely identify the range. We already have it between 90. So for y minimum, if I put 90, then it will hit the bottom of the viewing window. So I'm going to put 80. And maximum 140, but I'm going to write 150. And I'm going to put a scale of 20. Now let's think in terms of x. We're talking about time. X is time. And it's time in minutes.
Yeah.
I'm going to put 0 to whatever you want. 10 minutes? Okay, with a scale of 2. Here's the graph. So the low, what is the low? Because we have to answer the final question. The low is 90. The high is? So I guess Ari will tell the patient, ease up on salt. Your blood pressure is not 120/80. It's a little high. Your high is 140 and your low is 90.
Compared to this.
Compared to the 120/80.
What?
Let me see what happened here.
They carry the risk of that line, but okay, that's it.
This is what I used.
Maybe the girls, I think they
165.
just like that. That's weird.
Yeah, that's what I got.
I'm not sure. What did you get?
I just did.
It's okay. You get the same thing?
Mine
These look like
this.
2 balls.
Yeah. I don't
Okay.
know why.
Yeah. Is it in
The center's the same.
Yes, I see.
I mean, like,
Yours is a newer package.
yeah, it's a-
Yeah.
Are you in radians?
Yeah.
Am I in radians? Because this is the correct graph.
You are.
I had to check because sometimes, I don't know. Let's use just one complete interval. So b is 0, right? Because there is no adding and subtracting to this.
Yes.
So b is 0. b comma b plus the period. So 1 over 80. Let's do just that. 0, comma 1 over 80. Then we should see only one complete rotation and one complete graph. So from 0 to 1 over 80.
On the window.
Oh, be careful now with the scale.
Yeah.
So
It's right
1 divided by 80. And the scale, look, 0.0125. So I'm going to say the scale is 1 divided by 4 times 80, 320. This is one complete graph, absolute complete graph, with the minimum at 90 and with the maximum at 140. I'm not sure why this was different. Okay, that was sine and cosine. I still have time, yes. Okay. I would like to look at, and I'll come back to more problems and more graphs from tangent, at least tangent. Okay, I'd like to look at the inverse functions. This is 6.4. Inverse, we already did this because we already mentioned the domain and range for sine inverse and cosine inverse. Inverse functions. I'd like to work on a few problems there. Okay, so here's on page 460. Okay, page 467. Find the exact value of each expression if it is defined. Okay, so I like to look at problems from 3 to 6. Use a calculator to find an approximate value of each, 7 through 14. Then I would like to choose a problem from 15 through 20. And then I would like to go through problems like these. Ready? Okay, so let's start with the first one. So please choose between 3 and 6. Again, we are on page 467. Okay, we want to look at 5. Perfect. In 5, we are told find sine inverse of -1/2. That's part A. Part B, cosine inverse of 1/2. And then I will skip tangent. I'll come back because we haven't discussed tangent just yet. Okay. So I'm asked to find sine inverse of -1/2. Ready? Now remember, when we talk about sine inverse, we are specifically talking about quadrant 4 and quadrant 1, anywhere between -π/2 and π/2. So for a moment, I cover this, and I'm asking myself, sine inverse of 1/2. Which angle has sine 1/2? And maybe it's time now to rewrite that little chart for you. And I'll write it several times. So sine, cosine, π/6, π/4, π/3. How do I remember this? 1/2, 1/2. The square root of 3/2, the square root of 3/2, and the square root of 2/2, the square root of 2/2. I would personally, on any test from now on till the end of the semester and the final exam, I would write this on the moment I get the test, I would write it in. You don't have to, of course. Good. So now I'm asking myself, I covered the negative, and I'm asking myself, which angle has sine 1/2? π/6. But if I put π/6, will be here, but then will not be negative 1/2. So it has to be here. What is this? Between negative pi over 2 and pi over 2. That's it. Cosine inverse of 1/2. When we talk about cosine, remember, the answer has to be here till here, between 0 and pi. So cosine 1/2. Obviously, it has to be an angle in the first quadrant.
Right.
And I'm thinking, it's not the first one. It cannot be the first one. Because sine of 30 degrees is 1/2. It must be the other one. By the other one, I mean, okay, use a calculator to find an approximation, blah, blah, blah. For example, 10. I'm asked to find sine inverse. I'm sorry? Yes, because we didn't graph it yet. And I didn't show you the inverse. Tangent and tangent inverse are powerful functions. We need to work on those. So right now, I'm practicing what we just did. Sine and sine inverse, cosine and cosine inverse. Okay. So sine inverse of 1/3, I have no clue what that is. Because it's not among the functions angles that I have knowledge of. So I have to go to second sine, second and sine, 1 divided by 3. Before I hit enter, I have to think for a moment. Because the mode is in gradient mode, when I hit enter, I will get an angle in radians. If I don't want an angle in radians, I will change the mode to degrees. And now I go back and press enter. And I get 19.47 degrees. Now, if I have the mode in radian, I can always perform the change myself. So I'll copy the function, the previous entry. So this would be 0.3398. Does it make sense?
Yeah.
Because remember, roughly 57 degrees is 1 radian.
Yeah.
And this is roughly 1/3 of 1 radian. 1/3 of 60, it's 20.
Yeah.
So that's why this is 1/3 of 1. We can always go back and forth. Any questions on this? Okay. Yes, it was problem 10. In the same type? Oh, no, I just want you to know how, because we're going to have word problems, right, in which we may not have something very nice like 30 degrees, 60 degrees, 45 degrees, and we may have to find, yes, sine inverse of something else. Okay, fine. Yes?
No, I did that when I was trying to figure it out, and I kept getting like, why is it so low? It was in radians and not in
Right.
degrees.
Yes. So be careful because the answer will be very different, right? So what was it, 0.33 in radians or 19.47, I believe, in degrees. Okay, find the angle theta in degrees, numbered, rounded to 1 decimal. Okay, so let's say 18. Now this is still a simple type of problem because we are given a right triangle with one leg 30, the hypotenuse 70, and they're asking us to find theta. Not a big deal, right? Good, so what do I do?
Sine theta equals 30 over 70.
Exactly. So I write sine theta equals 3 divided by 7, or 30 over 70. Now, how do I determine theta? What should I do to both sides?
Sine inverse.
Exactly. So theta will be sine inverse of 3 over 7. Now, they say theta has to be in degrees. If that's the case, then I change to the mode in degrees. And I apply second and sine to 3 over 7. got 25.4. It says rounded to 1 decimal. So 25.4 degrees. Now, the next set is a very important type of problem. It's the basics of solving trig equations. We will come back to this extensively in chapter 7. So let's start with now. Okay, 21. We have sine theta equals 1/2. Find all angles theta between 0 and 180. They are telling us only between 0 and 180 degrees, which is what quadrants?
1 and 2.
Exactly. Satisfying the given condition. Exactly how we proceeded or how we followed the solution last time. I draw the unit circle. Which angle has sine 1/2? Because that part I know. If you ask me which angle has sine 1/3, I would say no clue. I have to use the graphing calculator. I can say, oh, it's 19.47 degrees. Say it again.
5 or 6.
5 or 6. 5 or 6. So careful how I present this on the graph. Once I understand this, you will not have any problems. What is this height? 1. How much is this?
1/2.
So it has to be right in the middle. The middle of 1. So this angle must be 30 degrees. And the angle that has a terminal side in the second quadrant must have the same what? Reference angle. Awesome. So then what is this? If this is 180 and the reference angle must be, so what is exactly? 150, right? Good. So then this equation has two possible solutions, theta and theta. What are they? You understand why I have to draw that horizontal line. Because this height here has to equal this height here, right?
Yeah.
This piece is sine of this angle, and this piece is sine of the big angle. That's why they both have to be 1/2. That's the reason why I draw the horizontal line, exactly at 1/2. Good. So this trig equation has two solutions. What are they again?
5 or 3.
Yes, 6. You mean?
6, yeah.
And now once they give us 0 to 180, we should keep it in degrees. It doesn't matter.
About 50 degrees.
Yes, 150 degrees, or you say pi minus pi over 6. Pi minus pi over 6,
5 or 6.
5 pi over 6. And I will say or theta equals 30 degrees and theta equals 150 degrees. Let's look at another one with sine. Sine, maybe not a nice one. This one, 24. Sine theta equals 1/4. Okay, where is sine positive? Still in 1 and 2. What is this height?
1.
But this is 1/4.
Right.
So if this is 1/2, my 1/4 should be here. This piece is 1/4. This piece is 1/4. This piece is 1/4. One angle, both of them are in standard position. They both start here, but one ends here and the other one ends here. So first I will have to find this, and then I will find this. I need a graphing calculator. I have no clue. There's no way I can determine this. So second, sine 0.25, and I get 14.5 degrees. So if theta equals 14.5 degrees, how do I determine the other one? The other theta. How will you determine the other theta? From, we subtract, the reference angle has to be the same, otherwise the height will not be the same. So this is 180 minus 14.5, whatever that is. I also want one in cosine. Here's another trig equation, 26. Cosine theta, they say, is 1/9, but we are restricted, they said, to 0 to 180. Yes.
What exactly is the question asking for these problems?
To solve the equation.
To solve the equation.
Yes,
Okay.
yes, solving trig equations.
Okay.
I'm given the equation, I'm asked to find the variable.
Okay.
The variable is an angle.
Yeah, got it.
The same thing here, sine of a variable is 1/4. What can the variable be? In this case, because we are asked between 0 and 180, I have to find two angles.
Okay.
If sine, which is not the case, were a negative number here, then I would have found only one, because this is a positive number. But between 0 and 180, I have two possibilities, two options for two different angles whose sine is 1/4. And I have to give all possible solutions between 0 and 180. Now for cosine, between 0 and 180, there is only one angle whose cosine is positive, right? Only here, right? So 1/9 is tiny, right? Is point blah, blah, blah. So what is this for cosine? 1. So I want something like this. So it's a big angle. That will have this cosine, 1/9. Of course, I can't do this by hand. I just wanted to explain what's happening there, because it's different than, now I have a vertical line for cosine, not a horizontal line. Horizontal line is because I measure it on the y-axis. Vertical line is because cosine is measured on the x-axis. So we go to second and cosine this time, and we put 1 divided by 9, and we expect an angle not far from 90. I don't know how close, but not too far. So approximately 84 degrees as we expected. So there is only one approximately 84 degrees. When we get to chapter 7, we will be asked to find all possible answers. And what will happen here? We're going to add to pi k, where k is any number of rotations. And here the same, plus 2 pi k. Okay. Find the exact value of the expression. I'm looking at 33, last one from this page. Cosine of sine inverse x.
So cosine is not positive?
Yes, because cosine is measured on the x-axis.
So would it be two answers for?
Yes, but we are specifically told between 0 and 180.
Oh.
If we were told, and maybe we should find it, if we were told anywhere between 0 and 360 degrees, then I would have found the other one. And let's find it. You're right. We should. Okay, so let's ignore the fact that we are only asked between these two. So how will I determine the other one? Here's the other one, right? But they have to have the same reference angle. So what will be the second one? Theta, approximately. Exactly. That will be the other one, and guaranteed that this second angle would have cosine 1/9. Good. So now here they're asking us to rewrite the expression as an algebraic expression in X. Okay. I need this especially for Calc 2. I know you're saying, okay, that's way far. Yes, but this is a very important type of problem. Okay. This is sine inverse of X. Sine inverse of X is, all I want you to say is number or angle. That's the answer. So let's start slowly. What do I plug in sine inverse? An angle or a number? Correct. So then what should the answer be? Good. I'm going to call that angle alpha. Call it the way you like. But I cannot call it X. Good. What do you think I am going to do to both sides to solve this for X? I apply sine, of course. I apply sine to this side, and I apply sine to this side. What do I have on the left? Assuming all conditions are fulfilled, of course. What do I get? Correct. And the right-hand side is sine alpha. Bear with me. This tells me this. This equation tells me this. That there exists a right triangle with an acute angle alpha whose opposite leg is, and the hypotenuse is exactly, because it's x over 1. What should this leg equal to? Well, by the Pythagorean theorem will be the square root of this squared minus x squared. Now I'm going back to my problem. What am I really asked to find? Of? We denoted that quantity by? Correct. So look here and please tell me what cosine alpha equals to.
Square root of 1 minus x squared.
Very important type of problem. Not for immediate use, but very important. Let's look at another.
And that's because that's adjacent to the angle, and that's what cosine means.
Yes. Yes. Adjacent over the hypotenuse. Any questions?
Can we use the trig as leads to solve that?
No need. No need. Okay, here's another for you. And we'll stop after that. One more. This one is slightly easier because it doesn't have variables. It has numbers. Let's say 27. Sine of cosine inverse of 3/5. Where do I start? Where do I start? Of course. So I have cosine inverse of 3/5. What does that mean? What does it represent? It represents what? It represents? Let's take it slowly. What is this that I can plug in cosine inverse? Okay, cosine is applied to angles.
Yeah, right.
What do I get as the output? A number. Cosine inverse is applied to
No numbers.
and returns. So what will cosine inverse of 3/5 represent? Awesome. I'm going to call it beta. What should I do now to both sides? Very good. So I apply cosine, so then cosine beta equals 3/5. Which means there is a right triangle somewhere on the planet with an acute angle beta. which means that I know something about what? Is, and the hypotenuse is 5. So now let's determine what? Yes. I have to find the leg. If I can't find that leg, then my hands are tied. Right, which is, these are the 3 Pythagorean numbers. 3, 4, and 5. 5 squared equals 4 squared plus 3 squared, so this must be 4. So then I know the answer. What am I really asked to find?
Sine.
Beta. What is sine beta? That's it. I'm sorry? 4 squared plus 3 squared is 5 squared. Or the other way around. 5 squared minus 3 squared is 4 squared. These are Pythagorean numbers. So 5 squared minus 3 squared is 16. I take the square root. And I get 1. This is really a 20-second problem. Say it again? No, it's really
half an hour, you mean?
It's really 5 seconds.
The classwork? Or?
Yeah, it really is 5 seconds.
Oh, jeez.
You have one on the chocolate. And you have here spoons and napkins. You should be happy with your food too.
Okay.
I have to keep one for Betsy.
Okay.